Yeah, thanks a lot for having me. It's a great pleasure to be here. It's a great pleasure to talk to practitioners and to also highlight a bit how we are encountering AI these days. And maybe I can give you some inspiration on situations where you might see the power of AI, but maybe also the challenges that AI poses to all of us. So today I would like to talk about this from a behavioral economist perspective. So first of all, let me briefly tell you what behavioral economics is about, more than just in a nutshell. So behavioral economics really thinks about how humans make decisions. Oftentimes we are confronted with easy or complex decisions. We have to think carefully about, for instance, savings and investment decisions. So there's this immediate gain that we could have from just going another round of shopping instead of just putting more money in the piggy bank. But there's also other decisions, like how do we react to incentives that our companies give us, or how do we make healthy choices? And of course, also, how do we interact with others? Do we delegate important tasks, and do we potentially also delegate to AI? So this is where I see the close connect to artificial intelligence and the power of AI. So first, AI is, of course, trained based on human decision making. And second, it's still the human decision maker that somehow needs to integrate and work with the AI in order to be extremely productive, in order to achieve better learning outcomes than before. So I would like to use the next 15, 20 minutes to discuss a bit of where I see the power of AI and where I encounter it in my academic daily life. So I will give you 3 areas. So first, I'm going to briefly talk about the experiences of AI in teaching. We already had this example of a student saying, well, I need to use AI because I don't want to write the thesis. I will also talk about how we use AI in the research process, and I'm also going to talk a bit about research results. So what are the impacts for firms when we think about AI, introduction of AI and productivity? So I'm going to highlight randomized controlled trial results where we can show whether productivity is improved or where the challenges are. So in the teaching process, there could be a long list of things I could talk about, right? When I think about preparing my teaching material or preparing these slides, I might use AI in order to improve the outcome. When I think about interacting with the students, I might also provide them with interactive teaching elements online, or I might use AI actually for the examination. Right? It poses also a challenge because we don't exactly know which examination formats we can still use. So when you think about writing a thesis, maybe that's the wrong way of testing the student's knowledge. In the research process, there's a bunch of different things I could talk about. One related to business is probably idea generation, but then also study design and coding is something that we encounter every day and where we can use AI very efficiently. And finally, as I said, there is now quite some evidence that really looks at the causal effects of AI on productivity in different contexts that I will talk about in a minute. So let me start with the teaching process and just highlight one example that we encountered at Ulm University, where one of my colleagues also thought maybe that's an idea that we could use and try out in a lecture to use AI as support for the student. So how would we do that? So for instance, when you think about your own times at university, maybe you still remember the good old days where you had to solve problem sets. So that's a typical thing many teachers use. So instead of just providing the lecture, students have to solve their own problem sets. Think of a math problem set or an econ problem set, whatever your field is. The classical process would be that the student works on the problem set and at some point in time receives the solutions online or maybe discusses the solutions in class. Now, there was first evidence from a randomized control trial in Harvard that highlighted that maybe students can become more productive when using AI in that process. The idea was to use AI tutoring, so using a chatbot in order to guide the student step by step to the solution. So one of my colleagues in Ulm also said, well, we can just try it out and use this idea, created his own customized version of ChatGPT for his lecture on environmental economics, where students then could upload the written solutions that they had and actually get a step-by-step hint on where the mistakes were and where the potential solution might lie. Now, I show this first as a possibility of improvement or productivity improvement, but I also want to give a warning, and that's another study that was published quite recently in PNAS, in the Proceedings of the National Academy of Sciences, which says already what the result is, which says generative AI without guardrails can harm learning. So I want to quickly show you what this RCT does. So what was the idea here? So these researchers collaborated with a large high school in Turkey with more than 1,000 students, in which they introduced some randomized controlled trial. So like in a clinical trial, some people were exposed to a treatment condition and some were exposed to a control condition. The students were experiencing first a lecture phase, so a standard lecture where the teacher introduces them to a math subject. And then they had to practice themselves. And this is where the randomized control trial comes in. So there's one branch, a control group, which just has the textbook and has to solve the problems themselves. Another group received a standard GPT. So basically, you can imagine like a ChatGPT standard version. And the third group received a tutor that had some additional guardrails. And I'm going to show you in a second what these were. The final outcome of interest was how would these students perform in an exam that is unassisted. So would they be better in the exam if they could not use the AI's help in the exam? What was the difference between this GPT-based and the GPT-tutor condition? Well, GPT-based, basically, as I said, is kind of an answering machine. So students could ask, for instance, what's the solution to the problem? And probably GPT would pretty quickly tell the solution to the problem. Whereas GPT-tutor was instructed not to give solutions immediately. So GPT-tutor was really one that said, well, I cannot give you the solution, I cannot give you the answer to the question, but let's start with the first step. So what's the formula for this and this and this? And then the student had to engage in working on the problem themselves. Now, what was the result? Well, in the practice period, so in phase 2, students that used the AI were more productive than students in the control group. Something that probably is suspected, right? So the AI helps the students. But interestingly, something different happens in the exam phase where performance was not assisted by the AI. So in the exam phase, in the control group, this is a normalized exam score. The exam score was about 0.28, and it decreased significantly in the GPT-based conditions, so where students were using artificial intelligence that had no guardrails. And even with the guardrails, they saw no significant difference between the baseline condition and the GPT tutor. So while there is some promise in using the AI, there's also a challenge, and I think the challenge here is really clear. Task efficiency, so performing well in the second phase, does not guarantee that students have the right experience. So when you automate a task, it might well be that the humans miss out on some valuable learning experience. This is, of course, just one task where you see this effect, but you can think of other tasks where it might also occur. So when you think about own workplace trainings, when you think about where you could implement AI to support workers, think carefully what the task is, what the typical learning experiences are that the people working on these tasks actually need and require, and then you can probably implement a solution that is also useful for you as a practitioner. I'm going to come back to this idea of what is the right task to use later when I talk about the productivity effects and where I show that learning is potentially also possible, but it depends on the task. So this was just one example from teaching. So let me briefly also talk about the research process. So in the research process, basically there's many things I could talk about, right? So as a researcher, you generate some new research ideas, you think about what the literature already knows, you start working on your project. Either you write a theoretical model, you do some mathematical derivations, or you start coding, then analyzing some data, and then eventually you do the write-up of the study and submit it to some journal. I don't have the time to talk about all of those aspects, so let me just talk about one or two. In particular, in the context of working with the AI, it might also be helpful to think a bit like what the AI is actually doing. So there's a really nice overview paper by Corey Neck, which talks about how economists could use AI. And I think one important recommendation they make, or he makes, is that you should keep in mind what's in the box. So when you talk about LLMs, for instance, it's prediction, not truth. Okay? So what's really important is, and I think this is a really nice anecdote, you can think of the AI or the LLM like a talented but inexperienced intern. So it is really capable of things. It's fast, it's well-read, it has a lot of patience with you. It's also eager to please. It really tries to help you. It was programmed to be aligned with that, right? But then it lacks your specific context. So you really have to be careful. Like as you are delegating to an intern, you have to explain what is your context, what is your problem, and be aware that the intern might not have the right solution. A difference to the intern is that these LLMs typically sound very convincing. So they might sound very authoritative even when they are deadly wrong. Yeah, so this is really important to keep in mind. So one rule of thumb the paper suggests is that, well, when you interact with the LLMs, brief them thoroughly. What is actually your problem? What do you want as a solution? Iterate the conversation and verify everything in order to be sure that what you get is what you actually wanted. So this is a general rule of thumb. This paper is actually a living paper. So it was published first in 2023. In 23, the usefulness scorecard looks like this. So basically, synthesizing and editing text was easily done with LLMs at that time, formatting references, translating code. all fine. Brainstorming ideas, debugging code, less so, but things have changed quite in the last 2 years, as we all know. So for instance, when you did literature research in the early days, there was hallucination. So you got sources, references that didn't exist. They sounded great. Even I apparently wrote papers that never existed. So this is really something that the AI made up at these points in time. But it has completely changed. So since 25, the latest, so this is also the latest version of this living paper. So the author still updates and says, what is new? What can we use? We have a combination of traditional LLMs that can access the web. We have reasoning models that are really useful when you think about, for instance, mathematical derivations that we have to do as researchers, and we have agentic chatbots. So things have dramatically changed. In particular, one example is just rewriting code, which works very well by now. So for instance, for us, it's really important that things are reproducible. So when I use statistical software, I want to write a code that I can understand and with which I can reproduce the results that I have originally created. So one example from my everyday research life comes from a situation in which we had written a paper. It was about classifying people into different types and then looking at how many awards do they receive or send in a company setting. It's not important to understand the exact study. The goal was now to simply change from 3 classes to 6 classes and produce the new code. So I could just write that. I'm capable of doing that, but it takes some time to do it. Now, for instance, with Google Gemini, I could simply use the statistics software code that I had written, submit it, say, I use this new variable with 6 instead of 3, write the new code, produce the new regression output, and give me the new graph. And the new graph looked as I wanted it. And this was really easily generated within, I would say, 5 minutes, instead of maybe 25 minutes writing the code on my own. So you really see the productivity improvement here in a very, very simple setting, right? Now, this, of course, holds also true for the reasoning models. So they're extremely helpful when you write down theories. But maybe what's most astonishing for researchers nowadays is agents. Okay, so agents are really not a future possibility. They are here, and we can use them, and we can very productively use them. So when you are kind of in the econ community, you're on different platforms, and there's many players that highlight what they are excited about. One professor from Chicago wrote this, and it's very small, so I put it in large on the right-hand side, that, well, Claude Code is insane. So he says basically, well, I work a lot with experimental data, running experiments online, and actually here's a task that would usually take like 48 hours, and I did it in 20 minutes. So what he's reporting on is anecdotal evidence that he could use Claude Code to produce R code, so an open source statistics software that is reproducible, that could retrieve all the relevant data from his online survey on Qualtrics, that could create tables and figures, do cluster analysis and so on, by simple natural language. So for instance, for the cluster analysis, he typed in, well, find types in the data, and then the software basically, or the Claude Code basically wrote the R code in order to do a cluster analysis on the data set. And this is, of course, something that really improves productivity, but it also changes our job. And it changes our job in an interesting way. We are less of doers. We are now more of managers and delegators, and we really have to think carefully what we want to delegate and how to think about the solutions that we get. Now, this is important for us, but it's probably also important for you as practitioners. I think there are a wide range of tasks where you could think about automating or using the AI as a complement, whether it's programming, data processing, and so on and so forth. But it's really important that you find the right use case. And I want to come to that with the last element in my presentation, which is about RCTs in firms, where we look at whether we can find causal evidence of the introduction of some AI system on the productivity. Why do I mention this here? Because there's a really nice study that actually also looks at kind of what is the right task to use the AI for. So there's a lot of different papers that I've listed here. They come from customer service, from consulting, from professional writing, and from coding, all basically finding some productivity improvements, in particular also heterogeneity in these effects. So the less productive workers are kind of catching up more than the really productive workers when you introduce these AI systems. And I just want to highlight one coming from a customer service situation. So this is a Fortune 500 company that sells business process software. It's data from more than 5,000 customer support agents. So they have around 3 million chats that they could use. And what they look at, what the researchers look at, is they look at a staggered introduction of an AI chat assistant. Okay, so staggered is important here because that means it's quasi-randomly distributed when people could use it. So we can use it as a mechanism for studying the causal effect of its introduction. So What is the AI tool? So you see the paper is from 24. Of course, the data is from a bit earlier. So they used a GPT-3 version. And it's basically a system that monitors the live customer interaction and provides suggestions to the customer service agent. So it's designed to augment and not to replace the agent. Responsibility still lies with the customer agent, and these agents have to solve the problem of the customer. Now, we can think of different outcome measures that would matter. So I just focus on the resolutions per hour as one example. So you see the distribution before the AI was introduced. So you see around 2 resolutions per hour, and you see a substantial improvement after the introduction of this artificial intelligence chatbot support. Yeah, so you see on average around an increase of about 15%. And interestingly so, first of all, again, effects are strongest for the low performers and also for moderately rare tasks. I'm going to talk about it a bit more. And what's even more interesting here, this is a task where people experience what the AI is suggesting, so they experience the learning process. And interestingly, at times where there was outages, where the system didn't work, also the worst performers perform better even without the AI. So here in this case, they actually learned something about how to do the task as well. So what the paper also suggests is that there might be kind of a sweet spot of what is the task that you can use in order to, where you can use AI in an efficient way. So for routine problems, the AI is super well trained because the training data is great, but everyone knows how to solve these. For very rare problems, actually the training data is not so nice. So the sweet spot is really kind of these moderately rare problems where the agents here, the customer support agents, maybe not fully memorize how they dealt with these semi-complex problems, and the AI can still help them and work as kind of an institutional memory bank that tells them again, hey, this is this particular problem. Another customer 2 years ago had the same problem. This is how you can deal with this. So there might be a sweet spot also in your context where you think about where can I use these systems most efficiently. So this was just very quick and in a nutshell. I hope that it becomes clear that there are some important conclusions that we can draw. I think the first one is really that it has enormous potential to use these systems. We are really witnessing a paradigm shift also in the way how we work in academia, but of course also how you work in business. And I'm pretty sure this shift likely creates a divide between those who adopt and those who don't adopt or adopt later. But adoption, of course, is not costless. As you all know, there might be a J-curve. It might be really costly to actually start setting up the systems in the right way and then using them. But I think not using them is not the solution. So my key takeaway is really that the question is not whether to use or adopt AI, but to think about which AI you can use and for which tasks you actually want to use them. So it's really a search for kind of your use case. And I stop here because we're going to have a roundtable discussion later that probably digs deeper into that. Thanks for listening.